Okay, so even though we're really supposed to be moving on in this lecture, I want to do one more with the arcos and the arctangent and all that. So because it leads into the next. Suppose that somebody says, solve for this. The cosine of x is equal to 1/2. So basically they want to know for every angle, remember, so here's some angle, the cosine of that angle is 1/2. And there's a couple ways you can think about it. Pretty much all you have to do is find one solution, and then you can find all the solutions. Now for the minute, if you want, you can just say, hey, let's restrict everything so we can invoke arcos. So it would be then, we'll take the arcos of both sides, the arcos of cosine x equals the arcos of 1/2, and these are inverse functions. That means the x just comes out, so this is arcos 1/2, and then you could plug it into your calculator, and your calculator would tell you that x is equal to pi over 3 or 60 degrees, whatever you want it to do. It would be much better if you just knew that the cosine of pi over 3 was 1/2. We're at the time, 4 or 5 weeks into the course now, where these certain cosine of 0 is 1, cosine of 45 degrees is 1 over the square root of 2, cosine of pi over 2 is 0. These basic ones you should know. But anyway, we need to draw a picture to figure out what all the solutions are, all right? And here is a reasonable unit circle. This is about 60 degrees, or well, something like that anyway. So here I know this picture now, or I'm getting to know this picture. I know it, you guys are getting to know it. This is the unit circle, r equals 1. So cosine is just what the x is, and this is going to be 1/2. That means that sine is square root of 3 over 2, because 1/2 squared plus square root of 3 over 2 squared is 1/4 plus 3/4 is 1. So now I need to think about it. So for sure, x is equal to pi over 3 is a solution, but how many solutions are there? Well, anytime I go around here once, if I add 2 pi, I'm certainly going to land right back in the same place, and it will still be 1/2. So the answer, one of the answers is plus 2k pi. And here this k is an integer. And why is that? Well, if I go around, and k is 0, it's just this answer. When k is 1, it's pi over 3 plus 2 more pi, it lands it right back in the same place. When k is 2, it just whips it around twice. When k is -1, it brings it around this way. Every integer, remember, integers are ... -3, -2, -1, 0, 1, 2, 3. I'm sure everybody knew that. I just wanted you to remember. So this is going to spin this around any way, any number of times, and it will always land back here, and any x that has this form is going to be a solution to this. Here's why you kind of got to draw the picture. Are these the only solutions? And I got burned on a physics exam this way one time really bad. I got an A in the class anyway, but it took a big chunk out of my test. So here's the deal. Where else is this going to be 1/2? And one of the things you'll think of is that, hey, Mike, cosine is periodic. If it's periodic, it's going to show up every 2 pi and whatever. Remember, periodic means that it's where the wave is going to look exactly the same. The period between wave crests or whatever you want to mark is 2 pi. It doesn't mean that it's not going to hit 1/2 again. As a matter of fact, what about if we do this? What if we go down minus pi over 3 degrees? Go down like this. Well, the x is what we're measuring here because the radius is 1. So this is the point 1/2, but this is the negative square root of 3 over 2. So the cosine, and remember cosine is an even function, so the cosine of negative pi over 3 is equal to the cosine of pi over 3, which is equal to 1/2. Similarly, so let's clean up some of this mess. So x is also equal to minus pi over 3 plus or minus 2k pi, because as we go around the circle this way, same thing, we're adding, and same thing this way. Point of caution, a cautionary tale here. There are a lot of people, all teachers are different. Mathematicians and English teachers tend to be a little more strict about notation. I am a mathematician. I hang out with too many physicists, though, which is what has corrupted me. But somebody might not like this, because this is usually you describe angles between 0 and 2 pi. So what is this? I would be fine with this answer right here. Well, what is this? Well, what is 2 pi? So we go 2 pi minus a pi over a third. What is this? This is 6 pi over 3 minus pi over 3. This is 5 pi over 3. It's a really good idea to be comfortable with certain angles and whatnot. But so it might be the case that they want you to write this, and then x is 5 pi over 3 plus 2k pi. I don't know. This is just depends on your instructor. For me, if you have this, I know that you understand the problem. So these have been the problems. We started out with the last lectures about arc sines and arcos and the special definitions. Remember, as soon as I did this, when we were asking for this problem, when we said, give me all the x so that cosine x is 1/2, we are not in a restricted domain here. In general, we won't be. When I decided to figure out one value of this, in some sense, I restricted the domain automatically. But once I found one, then I took off the restriction, and I figured out what all of the solutions are. And that's what we're going to start doing. We're going to get into trigonometric equations. And I might as well put the next one up on the board that we're going to do, because it's probably going to take a long time, and we don't have a terrible amount of tape left. But let's think about this problem. Suppose I have this. 2 sine squared theta plus 3 sine theta plus 1 is equal to 0. I want all values of theta, so this is true, if there are any. Notice this has the form ax squared plus bx plus c is equal to 0. I can use the quadratic equation to figure out a solution right away. For this moment, though, I think I'm just going to do this. This probably looks like this. 2 sine theta plus or minus something, which I'll figure out in a minute, and sine theta plus or minus something. Actually, this is plus, both of them have to be plus. The only factors of this are 1 or negative 1. Negative 1 times negative 1 is positive. If I check this out, you'll find here's my 2 sine squared theta. 2 sine theta plus 1 sine theta is 3 sine theta plus 1. This is equal to 0. We have to change the tape, and we'll be right back.